It's now my pleasure to introduce Peter Xavier, Vice President of Glencore Greater Sudbury Operations and Chair of Ontario Mining Association, to give some remarks on mining. I'd also like to again reiterate our thanksgiving, Peter, as the sponsor for today's event, and we look forward to listening to your expertise and your wisdom here this morning. Naha Miigwech, the floor is yours, Peter.
Thank you very much. Perfect, thank you. Well, thank you for the introduction, and thank you for the invitation and the opportunity to speak. I hope to give the mining perspective and really an opportunity to demonstrate, I think, where mining actually truly embodies the whole concept of circular economy. So hopefully, I know it's a diverse audience, and I'll try to do the topic justice, and hopefully at the end of the presentation, you agree that mining is really at the forefront of this concept. Next slide. Just to start off, just from a Glencore perspective, we're proud, and it gives us real purpose to our organization and our employees to provide a lot of the key products that the world needs for modern life. Of course, from a Sudbury context, we produce mainly nickel and copper, but we also produce cobalt, platinum, palladium, gold, and silver as well. And they're really the front end of the circular economy, which is producing the raw materials into the marketplace. Some of the challenges we face is we're dealing with finite resources. So we're always having to look for new investment opportunities. And those are getting, in more remote areas, and in Sudbury's case, getting deeper and deeper. And we don't set the price for a lot of our products. So we're not able to pass on costs to the consumer, which is a particular challenge, especially as we go to depth in Sudbury. But a lot of talk around new uses of metals, of course, as modern life continues to evolve, and talk about batteries or your cell phone, mobile devices, etc., communication systems. But even just the basics of life, whether getting electricity and clean water to your house, some of the things we rely on maybe don't even think about. So really a lot of uses for our products. And as the old adage goes, that if in terms of the source for raw materials, if you can't grow it, you have to mine it. And really there wouldn't be much of an agriculture industry without some of the contributions from mining. So next slide. From an economic perspective, we have Glencore operations throughout a large part of Canada. A lot of the base metal operations really focused around Ontario and Quebec. I'll focus just on the Sudbury contribution, long history of mining in Sudbury. Of course, our economic contributions support our employees and contractors, communities, First Nation, Indigenous communities, a key stakeholder. We have, I believe, very good relationships with all communities and collaborate constantly. Downstream users, of course, benefit from the products we produce, small, medium-sized enterprises, academia, research, and so on. And most of the benefit from our spend is really right in the community, and what's not in the community is mostly in the province. Just for rough order of magnitude, our combined operating and capital spend last year was nearly $1 billion. So, that goes a long way into, benefiting the community. And what's really nice to see is, over the years, a lot of the smaller companies that grew up in Sudbury started out supplying the local mining operations, have diversified and grown, and now serve the global marketplace. So a real sort of sustainability aspect of the economy here in Sudbury. Next slide. For Sudbury operations, what I'm responsible for, the only thing not shown here is the Port of Quebec operations, but we have 2 underground mines, a project in construction, our undertaken depth project, a mill concentrator, a smelter. All operations are underground hard rock now, so pretty limited surface footprint. Of course, there's still several old mines around in the Sudbury Basin, but Nickel Rim is an example of a newer one, built in 2010. A lot of modern design features from an environmental sustainability perspective, a very small footprint. And one of the aspects to mining that many people don't realize is before we even do anything, we have to think about closure and decades beyond closure, which certainly is normal construction, or if you're building, say, a high-rise in downtown Toronto, not the sort of thing you have to think about, but it's part and parcel with the thinking that has to be applied to bringing mining investment online. Undertaken depth, I'll talk about a little bit later, but our new investment as our current mines are coming to end of life. That's over 2 kilometers, 2.5 kilometers underground. So we're having to go quite deep now to extract the metals. When Sudbury first started, you could see a lot of the outcrops right on surface. Of course, a lot of the near surface deposits are mined out. Just for illustrative purposes, that's like going almost 5 CN towers underground. Next slide. This is a bit of a process flow, what's in and out of our Strathcona mill. So of course, we process the feeds from our local mines, along with custom ore. Custom is the junior market. Some smaller companies don't have their own processing facilities, so we take that niche contribution within the marketplace. And from that, we make several products, like nickel concentrate that goes on to our nickel smelter, a copper concentrate to our copper smelter in Quebec. And we make a classified tailings product that, there's a lot of discussion around tailings. Tailings, in layman's terms, is really ground up rock with all the metals removed as much as we can get out. And we use about 75% of it back to fill the voids underground as backfill. So that's a real good development that we've taken advantage of for many years. There is a smaller portion that's high in pyrrhotite that oxidizes and has a high sulfur content that we have to deposit in deep water deposition. And that's to ensure there's no acid mine drainage problems. Our water treatment system that's run by the mill is excellent. It's orders of magnitude below the emission standards from the regulatory authorities. So very, very well functioning system. And of course, there's a lot of research that's currently underway to look at different uses for tails or how to extract the metals that remain there. Of course, we've taken as much as we could, so it should tell you that what's left is quite hard to get out, pretty energy intensive, but there are efforts like that happening in academia and different research organizations, as well as some private enterprises that are looking at it. Next slide. From our smelter, it's really a hub of our sulfide nickel business. Of course, we process their own Sudbury feeds as well as our Raglan feed. Raglan is a mine we have in northern Quebec. A lot of talk about battery electric equipment in the marketplace, but good to point out here that we have an electric furnace here at our smelter. And we benefit from a clean grid here in Sudbury, so electricity is pretty much carbon free, as most of it's sourced from nuclear and hydro facilities. And so our focus historically has really been on emissions versus sort of GHG per se. But we always look at the context of where we operate. So Raglan, given they're very remote and run off diesel generators, have installed windmills to displace some of that. In Sudbury, that makes less sense, as we'd be essentially displacing clean hydro energy. So, we always have to look at what's appropriate depending where we're operating. You can see through all the effort of putting our feed through a mill and smelter, it's still just under half still waste. So it just gives you a sense of how much effort it is to isolate the metals. We do compete globally for custom feed into our smelter. And that's something we have to stay cost competitive and provide good recoveries and terms to continue to ensure that our smelter is full. And that's important because our local feed sources are declining. Secondaries is really a lot of waste products from other industries. A good example there of the circular economy. And it's a win-win situation. It's really what you call recycling. Win-win because it's materials that are very difficult to dispose of because they have metals in them for the facilities or industries that produce them. And good for us because we're able to extract the metals from that and put it back into the marketplace. And I'll go into a little bit more detail of that in the next slide. But another product that we produce is sulfuric acid. So we're able to convert the sulfur in our ores into sulfuric acid. That's an important, for agriculture, for water treatment systems, a lot of important uses in the marketplace. And the slag product is our waste product. Historically had been used in various construction activities. If you live in Sudbury, you'll see that in certain aspects. We've taken a more cradle-to-grave product stewardship perspective at present, but there perhaps could be opportunity for alternate uses for the slag product. Next slide. One of from a GHG perspective, one of our main sources, almost all of it, and we're pretty small. It's only just over 100,000 tons of GHG from our smelter. Comparatively, a steel plant might be several million tons, and most of that, 80+% is from coke addition into our furnace, and coke is a byproduct from another industrial process. We need it as a reagent in our furnace to create the right conditions to smelt, but it does take care of a waste product from another industry. There's not currently an alternative for that, so that's a challenge for us. It would likely need another type of organic to create the right chemical conditions. And it's really classified, I guess, as a fixed emission. We also built several years ago a calciner, which expanded our ability to process various feeds from other industrial processes, dries the feeds to be safely put into the furnace, and also, for example, battery recycling has a lot of inorganics, plastics, et cetera, that have to be taken care of and cleaned before putting it to the furnace. And I guess from a policy perspective, one thing to keep in mind is, we're a small GHG producer. We are at the mercy of the carbon tax and paying into it, and that's set to increase. But unfortunately, some of these, there's sort of a balance between reducing emissions and metals, and some of that comes at the expense of GHG production. And recycling, there's no way to take advantage of our recycling efforts, even though it's overall better for the environment. By recycling, we're increasing emissions and intensity, and the current policies are punitive towards that. So I think it's just an opportunity to back up and consider some of these things in terms of what's overall best for the environment is what we'd recommend as a path forward. Next slide. This is an illustration from an SO2 perspective. Again, most of the focus at the smelter has been around metals emission reduction and SO2 reduction. You can see quite a drastic change over the years in blue. The regulatory limits in green dispel some of the myth that regulation is the way to drive innovation at all times. We're really proud of the ingenuity and innovation in the team there that has found a way to reduce sulfur emissions quite drastically, and at the same time increase nickel production. So to do those things at the same time is quite the challenge. In our current project, we have roughly around $300 million of smelter emission projects currently underway from about 2015 to present. And you can see it's really indiscernible the effect that's having at that part of the graph. And I guess it just illustrates that it's getting tougher and tougher to sort of make that next little improvement. And we're at the phase now where we have to start investing into our underground mines as they're coming to end of life to continue our operations in Sudbury. But just these aren't off-the-shelf solutions you could pull off and just implement. A lot of the innovations that gave us this result was the result of the ingenuity of the team there and various piloting and technology and process changes to scale it up, put a business case together and implement them and see the results. So it's part of the challenge of why it takes some time over the years. And of course, we believe government role is there to create the conditions for innovation and investment, and understanding that these are complex and multivariant issues. We also, it's important because we're dealing with such long cycles, decades and decades from initial exploration to closure. We have to think about adaptation as climate changes, of course. We're monitoring our operations decades after they're closed. Progressive rehabilitation is very important. We've in the past been able to offset some of the carbon taxes through forest management. We're no longer eligible, but we continue to do those things anyways to help where we can. Next slide. We do participate as well as through the Nickel and Cobalt Institutes and the life cycle analysis. So it gives a transparent way for anyone to see our performance against other players in the nickel space and the cobalt space. As you can see from the graph, the bubble size is a reflection of the magnitude of the GHG per nickel ton. So you can see us in Canada are leaps and bounds ahead of most parts of the world. And that's where we don't want to see, movement of investment from, a Canadian type jurisdiction to other parts of the world, and want to continue the investment here. I think obviously that's the best overall situation. But that's, just a testament to the efforts that we've had over here with the last couple of decades. Next slide. I'll finish off with a little bit on mining innovation, so you could switch slides again. The mines are very, very small. GHG produce around 10,000 tons or so, mostly from natural gas that we need to heat the air in the wintertime, just given the northern climate, to make it hospitable and underground for our workers and also not to freeze our shafts. And so, when you look at innovation, we made a choice. One example is to go 100% battery electric equipment in our underground mines. And really, Northern Ontario is really at the forefront of pushing this. And we as an organization really pushed the marketplace for that when we made this investment decision back in 2017. The marketplace was very young. Our challenges were not the ones that create or make the machines. So we have to convince the marketplace to do it. We collaborated with a lot of other organizations to help push that marketplace, and the OEMs have responded. We had to work to create global standards so we don't have charging issues and other things that you might imagine. So it's a lot of effort behind the scenes to push this marketplace ahead, and we made the investment decision on the basis that we'd be 100% BV. And it just goes to show you where you can't take a individual sort of narrow perspective on these things, BV is a good solution because it hits multiple fronts. It reduces, of course, GHG because you're not burning diesel, and more importantly, less air underground means less to heat with natural gas. It also improves the hygiene underground, and it reduces a lot of the scope. But with less air, you need smaller fans, heating systems. Unfortunately, at depth, we have to heat the air in the wintertime and then cool it back underground to deal with the rock temperatures, and a lot less in smaller openings. So a big scope reduction. And that's really what made the investment decision to use BVs compelling. On the final slide, I'll just show a quick video. And while that sets up, I'll just a couple concluding remarks. I encourage anyone to look at the Mining Association of Canada towards Sustainable Mining initiatives. The OMA has a strong zero waste, zero harm, and productivity increase initiatives, and as does CMIC, or the Canadian Mining Innovation Council, has a Rethink Mining that's looking for zero waste opportunities and initiatives as well. So, and all those are strongly supported by the mining industry in order to achieve the ends we're talking about. So I'll let you listen to the 2-minute video.
What if?
What if?
What if?
What if?
What if we could start with a blank slate?
What if we could rethink how we design our mines?
What if our underground fleet was emission-free?
What if working alone no longer meant working by myself?
What if we could use technology to remove people from hazards?
What if I could go underground without leaving my office?
What if mine vehicles could drive themselves?
What if I could see the location and the status of everything and everyone underground instantly?
What if machines could sort ore from waste and leave the waste rock underground?
What if my equipment showed me what to repair before it broke down?
What if I can fly a drone to safely gather detailed information about the mine?
What if we didn't have to blast? What if we could just cut rock?
What if we could design a mine that transforms how mining is done?
What if we can all work together to make mining better,
safer,
faster,
and more efficient?
What if all the technology we need is already out there?
At Glencore Sudbury Operations, we are reimagining the future.
What if we started building the mine of the future today?
What if we've already started?
So apologies, a bit choppy, but you can access that through a link on our website. There's a series of a few innovation videos. So thank you very much.
Thank you. Thank you very much, Peter. Excellent presentation, and a lot of insights into the work that you and your team at Glencore are undertaking with respect to innovating your processes and the constraints and opportunities you're dealing with. And in fact, I remember as an undergrad, when I was in environmental science, one of the courses that at first I was not that excited about, but as soon as we got into it, opened my eyes to this world of mining and geomorphology, was that geomorphology and the whole notion of time, how looking at things from a geological standpoint and geological time really expands one's horizons. And I think we saw that particularly with the importance of our activities now in the timeline of development, as Gary noted, with respect to CO2 emissions. So innovation, I think, is a key thing we need to think about. And one of the questions that was brought up there in that video was a demonstration of the innovations that Glencore is undertaking, but that question of what if. So I'd like to kind of switch our minds over to this side of the equation now, which is the Albert Einstein part of this problem, which is figuring out what are the answers to those what if questions. And a lot of those answers are being undertaken by our next panelist.